So I'm here bringing the open source here to CPOS today. How many of you guys have heard of the MAME project? Oh, there's a number of hands. That is awesome. So I gave it a jazzy title where they said, come up with a cool title. So I'm like, MAME, the future of the past, which is kind of a bit overblown, but we'll go there. Of course, has open source, retro computing, and gaming emulation if you're not familiar with what I'm about to talk about. So a little about myself. My name's Ember, Gregory Ember up there. My friends call me Greg. And I'm an IT generalist. I've been here in the central Pennsylvania area for years. I have my bachelor's from Penn State University. But that's not where I started. I started with a nice full academic scholarship to University of Delaware. I also attended Millersville University where met my friend Joshua there. My IT interests include technical documentation, software preservation, digital asset management, knowledge management, data mining, technical research, intellectual property law, reverse engineering, and the open source community. And if that's not a mouthful, it certainly is. So I'm talking about MAME today. If you are unfamiliar with this project, it is a cornerstone of the retro gaming scene. MAME is a multi-purpose emulation framework. It is designed for software and hardware preservation. We originally were focused on coin-operated arcade games. The project dates back, it's only about 6 years younger than Linux, so it dates back a while. So, there's a friend at the Tech Lancaster meetups who says, Greg, don't date yourself. I'm going to totally date myself here today. Originally, it got its name from the acronym Multiple Arcade Machine Emulator, so MAME. In America, we pronounce that MAME. In other areas of the world, since this is an international project, they'll pronounce that MAME or various other pronunciations. But these days, the acronym has been phased out. Why? Because the scope has expanded to encompass pretty much everything. If it's got a CPU, if it even doesn't have a CPU, if it just has transistor logic, we can emulate it, we can simulate it, and we can output video, audio, and we can preserve that original program code, keeping its file signatures intact. We're in an authoritative database, probably the largest authoritative database of vintage entertainment, education, you name it, software in the world. In 2022, we celebrated our 25th anniversary. So we are just past the 26th. And this is a huge project. It's over 10.5 million lines of code, according to various analytics that I referred to. And according to the bot that constantly gets tagging us, it is one of the more popular GitHub projects because of the number of commits that it has, which I will get to later. So let's unpack all that. As we say on our website, MAME's purpose is to preserve decades of software history. As electronic technology continues to rush forward, MAME presents this important vintage software from being lost and forgotten. This is achieved by documenting the hardware and how it functions. The source code to MAME serves as this documentation. The fact that the software is usable serves primarily to validate the accuracy of the documentation. How else can you prove that you have recreated the hardware faithfully? This is also known as the playable games as a nice side effect clause. Over time, MAME absorbed the sister project MESS, the Multiple Emulator Supersystem. So MAME now documents a wide variety of mostly vintage computers, calculated video game consoles, handheld devices, in addition to the arcade video games that were its initial focus. So what do we mean by emulation? If you have been in the computer industry for many, many years, you will probably be a purist and you will refuse my definitions. But think about creating a virtual machine. So what's that going to need? You're going to need to create an environment in which these binaries can launch. They don't feel away from home. They're like, okay, this is my home digs, and I'm going to just start running, and I'm not going to crash. And so you're going to be intercepting the video, audio, inputs, outputs, I/O, and connecting that to your computer or other playable device. So with emulation, emulation has been around for decades because we need it. If you're a new hardware designer and you need to test your hardware design, but the hardware doesn't exist yet, what do? Well, you have an emulation of it. Back in the day, in the 70s or the 80s, that could involve serious mainframe hardware just so that you can get your simulation up and running. Very expensive technology. Also, eventually, hardware-based emulation for compatibility. So these would be like the circuit boards that you would install in a Mac to give it PC compatibility. And on those circuit boards would be an Intel x86 chip and some RAM, just to get the software familiar with that. And that's kind of stretching the definition. But the purists would say that that's the original definition of emulation. It was used to just do these little quick fixes, these little quick compatibility fixes. And if you wanted to get really low level, that's where you'd have a software simulation. Well, unfortunately for the purists, the definitions have changed. The gaming industry, the retro gaming crowd, has completely inverted that. So if you're looking for a more high-level recreation of an experience, we're usually defining that as simulation. And if you want a more low-level approach, we're usually defining that as emulation. Terminal emulation, so computing history, when we had mainframes and other sorts of microcomputers, maybe, we would need terminals to log in, and you would need to have a way to connect to that. That's why I have that little graphic there. Say that's a terminal emulation right there. It's showing Linux, obviously, but terminal emulation, and I'll get to later, MAME can actually emulate some original terminals now. Printer emulation, so like the HP LaserJets of the world became such a colossal language that all programs needed to speak it. Your printers needed to be compatible with this, so there is a printer emulation function to translate the language that your printer speaks into PCL. And yes, high-level simulation. So there'd be people who say, well, I want to play a game. I'm just going to completely recode it from scratch, and I will have preserved the original experience. Or I'm going to output all of my graphic calls. I'm going to twist all the polygons around and make it compatible with Direct3D or OpenGL. That, a lot of times, that's a bit of a high-level abstraction. And we also do call that high-level emulation when you do that. So 60s, 70s, some of the birth of emulation. With the retro gaming crowd, you'll be talking about, the Nintendos and the Segas of the world, and video game consoles, vintage computers. So a lot of that started happening because home computers were becoming a lot more powerful. With the Intel 486 chip and the Intel Pentium 1, it was a happening time that you finally had the horsepower to do some things that you were dreaming about. The 1990s, we're throwing way back to that. So like 1995, we first started seeing some commercial projects in the realm of arcade emulation. So that would be like Microsoft Arcade and Return of Arcade for Windows 3.1, Windows 95. Those were recreations. They may have had access to the original binaries, but they were not really programming emulation. And one of the first companies to do so was a video game firm called Digital Eclipse. They go all the way back to 1994, 1995. their first retro arcade game pack for which they had acquired the license. It was called Williams Arcade Classics. It was first published on the Macintosh under a different name, and then it was ported over to Windows. And when it was on Windows, it actually provided a lower level emulation. And I think this it was all happening at the same time. So this kind of inspired some of the grassroots open source coders and just closed source coders to go, oh, hey, wait, my computer can do this. Now all I need to do is get my hands on the original binaries to Pac-Man and I'm in business. Or I need the original schematics and I can get going. So we saw the rise in the late 90s of single-purpose arcade emulators. So these would be Windows, Mac compatible programs that only job was to play one specific game. And so this was a very brief window of time that this lasted. And eventually people moved on to multiple arcade emulators because arcade games shared a lot of the same hardware. If we're talking about the vintage 70s, 80s classics. They would have a lot of times the same CPUs but different video chips, or the same CPUs but different audio chips, or different CPUs and the same audio video chips. So with a multiple arcade emulator, you could combine all that into one distributable and you could get going. The community mostly tends to acknowledge David Spicer's work on what was originally called Das Arcade and later renamed Sparcade as one of the first, if not the first, multiple arcade emulator. And so I want to give a shout out to David if you're watching. So I pulled this list together from a database I helped work on back in the day called Caesar. And this has a list, just as an example, of some of the original single-game arcade. I believe they list about 100 that lasted mostly from the late 90s into the early 2000s. And I have a list of multiple arcade game emulators, and there were a lot. It was at least 120 for various operating systems. And some of them were ported to various operating systems. It was start on DOS, get ported to Windows, get started on Windows, get ported to Mac OS, if the source code was available. Which gives me a nice segue, because I'm here to talk about MAME. Our project founder, Nicola Samoria, he is Italian. He was active in the 90s as like an Amiga utility designer, developer. And he was interested in creating little puzzle games, and he was interested in a lot of things. He was a math major at University of Siena, and he graduated there in December 2002 with a laureate degree, so that's kind of equivalent to our bachelor's, although I remember some of our discussions back in the day, and some people were saying, well, no, it's more like a PhD. So Italy had their own thing going on. Europe tends to do that. When he wrote his thesis paper, he wrote it about the project that he started. And back in the day, I had the free time to help him with his citations. So he gave me a little shout out in the credits. I'll provide a link to that later. But so MAME history, multiple arcade machine emulator, late 1996, early 1997, Nicola developed single game emulators, just like the rest of the crowd was doing. Crazy Climber, Ladybug. He called them all like Crazy Climber Arcade Machine Emulator, or CCAME, Ladybug Arcade Machine Emulator, or LAME, Mr. Doe, et cetera, et cetera. So December 24th, 1996, he had a couple of different Pac-Man emulations going on. He was like, well, I can merge these all together because they're all the same hardware platform. And so he released Multi-Pac. That lasted for a hot minute because later he added, I think it was Rally X, Ladybug, one of these games, and he's like, well, this name no longer makes sense. And so we're doing more than just Pac-Man. So he renamed the project MAME, the multiple arcade machine emulator. And he opened up his source, and I would say at the time, that was fairly uncommon, and that got things moving incredibly quickly. So MAME 0.1, February 5th, 1997. These were the first 5 working games. Pac-Man, Miss Pac-Man, which was a bootleg. It wasn't the original ROMs. Crush Roller, Pango, Ladybug. These are names you can Google later. There are some great websites to pull up information about these classics if you are unfamiliar with them. But as you can see, it kind of exploded. So I'll just let me grab my laser pointer here. So here is February 1997, and the last time this chart was updated was, 6 years ago, August 2017. And there's a lot of terminology here at the top, which I probably don't have the time to explain, but the point of this graph is to show that the number of emulated systems, working, partially working, non-working, grew dramatically. At this present date, we are approaching 40,000 emulated systems. That is a lot, and many of those systems load their own collections of software, so you add in those titles, and it's even larger than this graph can really indicate. It's massive. And I will get to talking more about how that works in a bit. But I just kind of wanted to use this as an example just to give you the idea of how the scope exploded dramatically. And you'll see there's these big bumps around 2012 and 2015. And you're like, oh, what's happening there, Greg? I'm going to get to that, hopefully, because I'm trying to cover a 25-year-old project in less than 40 minutes. I'm going to throw a lot at you guys, and I'm very sorry about that. I would have liked to do a little more condensed version. But so MAME history, so this is a kind of indication of the early days. Developers flocked to this mostly because it was open source and provided them a framework from where to build off of. And so the number of releases, in the first month, it was practically every day, then it moved to every week. I'm actually cutting off the bottom of each of these years by at least another 10 to 15 releases. So we moved from a just 0.1, 0.2 versioning system to a more like beta release candidate, thorough official release kind of model. And it's changed over the years as various release managers came to the fore. So it's organic. People who are looking for a rhyme and a reason to it, it's really only been in the last 7 years where we've really kind of had a regular monthly release. But you can probably not read these URLs because I visited them, but I will drop them later. These URLs can take you to information about these old releases and what was included in them. But when I'm talking about emulation, I'm talking about the engine. Yes, it supports a lot of games, but our distributable was the engine. It was up to the users to support it with the games that they had in their collection. But I was talking earlier about how this kind of thing started accreting developers and growing by leaps and bounds. And this was an online comic. We had some fanboys in the emulation scene back in the day, and online webcomic that said they called us the Borg. That if you're familiar with Star Trek, that they will assimilate everybody. That's what they called us, and that was not always a joke. Some people meant it to be hurtful, but I think we created this thing from which people drew inspiration. They wanted to be a part of it. They wanted to. In some cases, we had single game emulator authors who were like, okay, well now I'm done developing this. I want to release the code. So they gave it to us. Not the way things would happen these days, but you know, it was the early 2000s. It was still kind of open source, was still kind of new in a way. But you guys are also surely familiar that it's been going on way since the mid-90s. Yeah, they called us the Borg. And we kind of assimilated all these single game emulators, and all the developers, a lot of the developers came along with them. So I have a joke here in the header. Changelogs as huge as Godzilla 2000. So I'm going to kind of give you a taste of that. Except I'm in the wrong video mode. 1 second. It's probably going to completely screw me up. So, old releases. So we just had a release 2 days ago. So for those of you who thought, oh yeah, I remember MAME, but MAME is dead. MAME's not dead. It's still going on. Oh, PowerPoint is fading it out. There we go. Nope. Yeah, so we just had a release 2 days ago, and even the blog post about it is, 5 paragraphs, 6 paragraphs, 7 paragraphs, 8 paragraphs. We talk about some of the things we've fixed because, and we do that because the actual changelog is, this is a month of commits. And some of this is as simple as like, oh, well, we just added a new file signature to some software that came out of the woodwork, and some of it represents major hardcore development, and it became so big. We used to have the release manager organize these notes, and he'd have it all sorted. We can't even do that now. It's too big. So when I say it's a lot like Linux, it's a lot like Linux in that the changelog is freaking enormous. But in other ways, it's not like it at all. There we go. Sorry, nice segue there. So here's the punchline to my joke. Japanese movie, I think they're called Toho. They own the Godzilla franchise. In around Y2K, they made Godzilla 2000 with the vintage style man in a rubber suit, and they needed a way to indicate that aliens were hacking all the computers. So they need pages and pages of text. So some eagle-eyed person on the internet said, hey, do I see the name Nicola Salmoria going past me? And he freeze-framed it, and sure enough, we're there. So some of our developers actually got some hit Hollywood, which is pretty hilarious. The MAME emulation framework. So this is way too long for me to talk about, but I, again, will try and give you a taste. Just a taste. There we go. Where's my, there we go. So I'm here on GitHub, which is where we are living these days. And I'm in our historic MAME repo, which was created for us by one of our contributors. And we have kind of the, let me try and, there we go. That's better. So we have the source code to, at random, Pac-Man from 1998. We have a lot of comments at the top talking about how the memory is mapped out, how the CPU talks to these memory, some of the I/O, where to find the I/O addresses. Once you get past the comments, we start defining some of these. And at the time in 1998, we were fully C. C was good for us. It was very portable, which allowed us to get ported and forked to a variety of platforms. But we also created kind of our own language. We had a C macro language, for those of you who are familiar with macros. And it made what's called the driver, where all these definitions exist, pretty easy to understand. And I'm still kind of feel like a layman sometimes talking to some of our developers. But I was able to understand this and make some additions of my own. And it talks about where the dip switches are in the circuit boards and what happens when you adjust those switches and how the joystick. And it's all this definition language because the actual emulation code exists elsewhere in the source. So this is all just kind of defining how it's all connected and what it needs to load. By the time we hit MAME version 0.253 just 2 days ago, this has been, well, first of all, the comments are much, much longer. We have a lot more research here by all sorts of developers. And this is not for one Pac-Man game. This is for dozens on the same hardware. And now we're doing C++. So what was cool back in 1998, we had C, if we needed some performance optimization points, we'd hit some tightly wound assembly. But now we're doing C++. It's actually C++ 17. Makes us a little less portable for some of the vintage platforms, but the trade-offs are pretty good. I've got to go back to my PowerPoint. Hopefully. All right, there we go. So like I said, ports and forks. Over the past 25 years, we have been ported to, I say it's like Doom, right? Anytime somebody hacks a new hardware platform, they're like, all right, let me see if I can put Doom on it. So we're kind of like that. Acorn, RISC OS, Adobe Flash, believe it or not, Amiga OS, just some of the highlights here. This is a huge freaking list. All sorts of versions of Linux, obviously IBM OS2, for anybody who remembers that, BOS, Haiku OS, MorphOS, which is an alternative Amiga operating system. If you will say, well, I want to play this on my Nintendo, don't worry about it. Somebody has ported it. Somebody even ported it to the Nintendo 64. He had access to the software development kit. He'd never released the source, but he did release the binary. I wouldn't really recommend it these days, but you name the platform, it's been ported. It's probably more likely to find one. It's hard to find one that has not been ported to. This also includes some classic cell phones like the Epoch 32 Scion, or the Nokia 9210 communicator, or Symbian Series 60 from way before the era of smartphones. People were still kind of just like, can I make this work? But obviously, our home platform for many years, since 2001, has been Windows. Obviously, it's a nexus of gaming. These days, not so much. Obviously, everybody with Steam Links are running Linux now. And even Mac OS X is punching above its weight class these days. So but I just want to kind of give you an idea of the size of that. I'm going to keep moving on. What makes MAME great? So obviously, the open framework. The available source code was a kind of a game changer. We were built off of some other open emulation cores when we first got started, and eventually we made our own. We made them our own. Rapid development that was providing a big build for the community. The quest for accuracy, I wish I could spend an hour talking about this. We start at a higher level, and as we're like, okay, we're familiar with how the CPU works, but it's a microcoded CPU, so how do we get accurate to the microcode? Or, well, the CPU, we understand all the opcodes, but we'd like to be accurate to the timing of those opcodes. So as we gather information and we gather more developers who are intimately familiar with the hardware, we descend lower and lower to what we consider higher and higher accuracy. The problem with that is it tends to increase the performance requirements, but we just consider that as just a trade-off. Portability, like I said, it's a reference emulation, which means we're also not concerned about the performance, because we want people to build from this and go, this is how we have documented it. If you want to make something that performs faster by making some hacks, go to it. But we're here to show how we consider that the hardware works. An incredibly powerful debugger. I wish I had the time to really show that off. General availability of developers. The team has been huge. Currently, we are officially around 60 developers and at least 500 or 600 contributors throughout the world. As I mentioned, the understandable drivers, which kind of builds from the Lego-like construction. Once you have a CPU emulated, it's easy to hook that up to other building blocks of the hardware. And I've known people to prototype hardware that they're developing, kind of retro hardware, by building a driver in MAME. And just a fantastic user community, which is everywhere, every place, and around the world. There's obviously been some issues over the years. This is not without drama, but it is a good community. I do enjoy it. So to quote Synopsys OpenHub, I know GitHub has some code analytics too, but I liked OpenHub because it had something that was easily quotable. So MAME has had 86,270 commits made by 618 contributors, representing 10.5 million lines of code. Asterisk. Where they went wrong with analysis, they started from when we made our subversion/Git public in December 2000. December 2007 is how back the archives go. So before that, before any sort of versioning systems, well, we were in the diff patch kind of you release the code, somebody sends you a diff file based on the changes they made to the code, you patch the code, which is a lot to track, but somehow Nicola was tracking hundreds of contributions by the diff patch method for many, many years, and estimated 3,200 years based on the Kokomo model, starting with its first commit. And their analysis would change if they knew the full story. So what makes me eligible to talk about that? Sorry, Steph. Story time. You may ask yourself, how did I get here? So yeah, my name is Greg, but I discovered MAME as a user. It was 1999. I was in college at Millersville. And it was just mind-blowing to me. And so I just started obsessing over it, and I became a power user. So I made the transition from user to power user. So later I was helping as part of the fan community. I was contributing on message boards and mailing lists. And that kind of got developers' attention. I was kind of omnipresent. And so they said, could you help us? Because there's this one technical manual that I've always been looking for. And so we, oh boy. So it turned out I was gifted at that. And so day one, I introduced myself on the mailing list, and they gave me all these quests. One took a week, one took a month, one took a year, one took 10 years just from day one. And they were constantly throwing things at me, and I kept up to date as best I could. I was gaining these skills in research because I kind of was up to date with the 90s search engine technologies, power user of those too. And I kind of got involved in some communities to help grow that and gain skills. And I was kind of the gopher on the team. You know, go for this, go for that. I was a newbie. I was getting their coffee. But over time, I created hats. I became a message board moderator. I became a community moderator. I got ownership of various things. At one point, they trusted me. They're like, okay, well, you have commit access, great. And I slowly accumulated all these hats, and I was straining under the weight of all these tasks, and obviously there will be repercussions to that. So I said I had a full ride to the University of Delaware, right? Yeah, what do you think will happen when you obsess over a project like this? Sorry, Mom and Dad, but I kind of blew that scholarship. And at Millersville, I ended up on academic probation, I'm embarrassed to say, but I got myself sorted out. Emulation does not happen in a vacuum. It is legal-ish. It's kind of gray area. Court, how am I doing? Wrap it up, all right. In 2010s, we made contact with their sister project MESS, which was doing the calculators and the consoles. We merged the projects, and then, and this is worthy of a talk in and of itself, we relicensed 10.5 million lines of code. Up till that point, it was a custom software license, and we became GPL version 2, which is controversial to some, but over 90% of the code is BSD license, which is even freer, according to some. We also, through a very strange story, ended up with a US registered trademark, of which, that's another hat I'm wearing. I own that, and I'm supposed to defend it. I think other people could do a better job, but I've done it okay. So when we held elections, going from kind of the benign dictator-in-chief model of an open source project in 2016, I was one of the people elected to the administrative board, I think because I'm a pretty inoffensive guy. But there's some other people on that team who are visionaries, who are expert reverse engineers, and who I treasure our internet relationship with. We gained a lot of benefits from relicensing. We actually have a license that's legally defensible. There are lawyers who will defend that license. We haven't arranged that yet, but we might. MAME ended up in the Museum of Modern Art as part of a video game thing. And museums desperate to use us, but they're like, we charge for tickets, and your original license says no commercial use. So we changed that because we wanted to be used, and the commercial industry was like banging on our doors. Please change this rule. And eventually, relicensing to GPL allows them to do that if that is what they wish. It's so easy. Even Capcom can do it in 2019 with the Capcom Arcade Stadium. List of our developers there, because they can't just credit the MAME team because we have no copyright attribution. As my friend Frank said at Game Developers Conference 2019, every arcade game available on modern platforms should be thanking MAME team in the credits. We're all using MAME. And that's pretty true. There's been a lot of retro use. What is the coming future for MAME? Well, what's hot in MAME? Everybody has an opinion. There's all sorts of things. Synths, I'm a huge, passionate lover of electronic music, and I've had my own synth, and I would play this YouTube, but I'm running out of time. Power Mac emulation is happening. Low-level Power Mac emulation has never happened before, really, not to the level which we're going to do it. Pentium 2 emulation, there are others in that scene, but our PC emulation has matured over the years. I'm also a big fan of 70s and 80s handheld games. No, don't play the YouTube. We heard you like pinball. Pinball is coming to MAME. Don't know when, but it will happen. We already have a sister project which does that, and we've been in talks with them. We also talks of doing our own. We're going to modernize the UI, which is kind of dated at this point, get some hardware graphic acceleration maybe while we're at it. That's always been difficult for us to achieve, but with modern graphics cards, it's been opened up. Laserdisc, full motion video games. We are archiving at the laser pickup with some custom hardware. And discrete circuitry and TTL logic means we can actually emulate Pong, which never had a CPU. It just was game logic printed onto circuit boards. So for some people, I haven't done a very deep dive. This was very, very surface level. I was trying to cover a lot, and I've gone over time, and I apologize. So for you to check out more technical interviews, check out our official YouTube channel, which is linked from our homepage at mamedev.org, I believe. And I set up a playlist of presentations. We also have some longtime contributors. David Haywood was at Play Expo just a few years ago in the UK, in Blackpool. Ryan Holtz just the other week released a 30-minute retrospective on what MAME did just in 2022. And he didn't even hit all the highlights. It is a very good video. So check us out at mamedev.org. If you'd like to contribute, we're on GitHub. I would say most of the easy arcade stuff has been taken care of. But if you love vintage computers, vintage handhelds, or you are a hardware wizard and you think you can tackle some of the harder arcade stuff, contact us. We are open to communications. You can easily become a contributor, or you can fork our project and make your own derivative. That happens a ton. My thanks to, well, the entire development team, particularly Randy, who got me into this business, some of my local crew, as well as our international crowd project founder, Nicola Salmoria, computer history museum contributor, Al Casau, our release manager, Vas Crab, former project leader, Aaron Giles, Roberto Fresca, who's a great frontman for us in Spain and Argentina, and the list goes on and on and on. And I just really want to thank everybody and thank you for coming out today. You can find me on the internet with my name is Stiletto, which is regrettable this many years in the future, but online handle Stiletto at github.com/Stiletto with a 0, or Twitter with a 0 and an underscore, or at my online hangout at vogons.org. And I hope you guys have a great day at CPOSC today. Go see as many speakers as you'd like, and I will be emceeing some of the rest. So I will see you then.